Hello, my name is Darren Lim. Today I'll be talking about partial derivative of vector value function. I'll proceed this chapter by going to the next slide. What is partial derivative? Partial derivative is a function of more than one variables is these derivatives of the function with respect to one of its variable while the other variables remain fixed. So for example, fx, y, f bracket x coordinate and y coordinate equals to 2x squared plus 3xy plus 6x plus 7y. So if we derive it, it will be if we derive it to the with the respect of x, thus it will equal to 4x plus 3y plus 6. If we do a second derivative towards the function with respect to x, thus it will equals to 4. When we derive it with respect to y, it will be it will be 3x plus 7. When it is derived for the second time, it will equal to 0 because there's no more y value there. So for the last example, it will be when the bottom is either y or z in which position, the answer will still be the same at 3. Which is you can see from this. Alright, now go to the next slide. What is vector valued function? Vector valued function is a function whose domain is set of number, who is a set of a number and whose range is a set of vector. So in the vector form, you can see the usage of the I, j, and k. And for scalar form, it will be basic a bracket, ft, gt, and ht. So in the next example, partial derivative of vector valued function. If f is the vector function, thus you can see that f1 bracket x coordinate, y coordinate, and z coordinate bracket, and it's repeated f for f2 and f3. Then partial derivative with respect to x, f over x, and thus we use the vector form found initially given and substitute it inside. That's all.
Hi everyone, today I'm going to continue to explain about the partial derivative of vector value function. So the question is shown here, a equals to x squared yzi minus 2xz cubed j plus xz squared k. b equals to 2zi plus yj minus x squared k. So the question is find b squared over dx squared a times b at point 101. So first you have to do the multiplication a times b. After that you have to differentiate the result for 2 times. Lastly, you have to sub the value 101 into xyz. So this question will be 10 marks. So next will be the solution. First you have to solve for a times b. So for a times b, you have to do the matrix form like this. So this will be ai, aj, and ak. This one will be bi, bj, and bk. This two is for you to easier to multiply. Okay. So from left to right, you times together and you add a positive sign. So this one you will get 2x cubed z cubed. Cos positive, negative, negative become positive. And this one also same, you times together, you add a positive sign. All together, add a positive sign. But from right to left, it's also same, you times together, but you have to add a negative sign. So for this one, it will become positive. This one will become negative, and this one will become positive. So after you times together, you get this. After that, you do the factorization. Means that you group I and I you put it in one group, j and j you put it in one group, k and k you put it in one group. So you will get this. After that, this equation will become easier to differentiate. So for this part, you have 4 marks, which is a times b, this one, the formula for 4 marks, and the result for 2 marks. Okay. That's all from me. Thank you.
Next, we solve for the first partial differentiate relative to x. So this is the result of the cross product. So after we using the first partial differentiate, we will get 6x squared z cubed minus yz squared for I plus 2z cubed plus 4x cubed yz for j and plus 2xy squared z plus 4z quadratic is for k. And then next, we were solving for the second partial differentiate for relative of x. So this is the result for the first partial differentiate. And then we will found the yz squared and 2z cubed and 4z quadratic is a constant and which will be a 0 after using the second partial differentiate relative to x. So we will get the result 12xz cubed for I, 12x squared yz for j and 2y squared z for k. And lastly, we will sub the 101 to xyz. So by using the result of the second partial differentiate relative to x, we sub the 101 to the xyz. So we will get 12 times 1 times 1 for I and 12 times 1 times 0 times 1, which is 0 for j, and 2 times 0 times 1 is 0 for k. So the answer will be the 12i. That's all for me. Thank you.